In this video, we will continue to work with the course class. Here we'll introduce the concept of shallow copy and deep copy related to copy constructors. Let's just very briefly go over the course class. The course class has 4 private data members. One of the data members is a string pointer through which we dynamically allocate memory. And then the course class has a number of methods such as get course name, add students, drop students, get students, and so forth, get number of students as well. It has a constructor and destructor also. The implementation was already discussed in earlier videos. And in the main, we have seen an example of the main program that tested the course class. Now in this particular video, we're going to again go over the copy constructor. The copy constructor is called when we declare a new object and initialize it at the same time. So this is one instance. Line 32 shows you one instance where a copy constructor is called or invoked automatically when we create a class and initialize it at the same time. Course 1 already exists and course 1 has 3 students in it already. Now every class has a default copy constructor. So when line 32 is executed, the default copy constructor is going to be invoked, and there will be a member-wise copy of the content of course 1 onto course 3. In particular, the pointer data member, the students pointer data member, the address of students is going to be copied over to students in course 3. And the issue or the problem with that is that now you have 2 courses, course 1 and course 3, both of them with the students data member holding the same address, pointing to the same shared memory location. So in fact, if I start looking at the number of students in course 3 and print students in course 3, you will see the same students as the ones in course 1, and that's expected. That's what we want. After all, we copied course 1 onto course 3. This part is expected and it's fine. The issue is that when we basically go on to course 3 and let's say you add a student to course 3. In line 33, after copying course 1 onto course 3, we add another student to course 3, Jack. So course 3 now has 4 students, right? And then if we go on and take a look at course 1, we see that student Jack is also added to course 1 as well, indicating that course 1 and course 3 actually share the same dynamically allocated memory location. So if I run this program, you will see that there's course 3, it's got 4 students, and right after that I've in this loop that you see here, I've asked for printout of course 1, same number of students are printed. Now this is not a desirable outcome. We would like course 1 to be copied over to course 3, but we don't want them to share the same memory space basically, so that when we change one, the other one would be changed as well. So that's not desirable. For that, we need to supply a customized copy constructor and avoid or override the default copy constructor. And that's the next thing we want to do. We want to actually supply this course class with a new copy constructor. All right, so let's move to definition of the class. I've already placed the copy constructor. This line was added, line number 10. to the definition of the class. That's the copy constructor. The header of this function is the name of the class course, and the parameters are constant, course reference, and then the name of the parameter is course. Conventional way of defining a copy constructor. And then for the implementation, we go to the implementation file. Here is the implementation of this copy constructor. First, I've entered a line indicating that the copy constructor is being executed, line 46, just a message. And then copying members of the parameter, data members of the parameter, over onto data members of the calling object or the implicit object. So this, that means the calling object, implicit object, course name is equal to the parameter's course name. So we copy that over. Same with number of students. We copy the number of students of the parameter course over this newly created object. Same with the capacity. And then line 50 is an important line where we actually allocate memory for this newly created object. It's new string capacity. And then follow that up by a loop in which we copy individual students from the parameter, the course that's parameter, onto this newly created object. So one by one, the students are copied over. And then we go to main, and in fact, executing the same code that we executed earlier. Let's take a look at that. Run that. And then what we see here is number of students in course 3. Remember, we copied course 1 over onto course 3. So number of students in course 3 will be 4. We added Jack to it. This is the printout of students in course 3. But then as we go over course 1 and print it, the 4th student is blank. There's nobody in there. Jack was not copied over to course 1 because course 3 and course 1, they have separate memory spaces. So every time you have a pointer variable in your class and that pointer variable is going to potentially allocate dynamic memory, you have to supply your own copy constructor.